Hey bunnies, welcome to Developer Diary episode 10. Now, in the last episode, we worked on changing of some scripts and we figured out how to charge the player, and we also figured out how to make the enemy go from transparent to not transparent. Yeah, now there were a few issues with the code initially. We obviously had some issues with the spawning and stuff, so we're going to fix them at the start. Before you start asking, I have changed the code editors. I was using Notepad++, but it doesn't read the Unity library. So like transform, game object, those things, they don't come up as actual things. There is some issues with Studio Code. For instance, I think there's just an automatically setting which assumes I'm trying to do something. So every time I type transform, if there's another variable with anything similar to the word transform, it assumes I'm trying to type that, and it automatically types it out while I'm typing, which I'm sure I can turn that off, but I don't know. So yeah. I'm not using Notepad++ anymore. I'm using Visual Studio Code. It's also more visually fun for you guys because it's it's not bright as hell. It is also a free code editor, and it works with a lot of languages other than C#. So if you want to learn how to program, that's a pretty good way to start. So the last episode, we were beginning a new script. I forgot to add functions, like add the code to the functions. I did them all in other functions and update. To start with, I moved the charge code into the charge function so I can reuse it whenever I need to reuse it. I can call the function rather than doing it at specific times. It means that the code works a little bit less like down a line, and I can just go, okay, charge now, and it will just do it. Yeah, so when we started, I tested the game and realized there was a huge issue with our code from the last session. The enemy spawns inside the circle. We wanted it to spawn outside the circle. I don't know why I thought it didn't, but it spawns inside the circle, not outside. So it's not the radius around the player, it's like the radius inside next to the player. Not good. When I shine a light at the enemy, it forces it to respawn before it charges. So I'll flash a light at it, then it will teleport, then it will attack. Which obviously you're not going to be scared if something's attacking you from behind, right? It's just going to disappear and hit you from behind, and it's confusing. Like you shine a light at something, it disappears, and then you get hit. Like, did you do right? Did you do wrong? You don't know. There's no feedback to tell you that something's bad. That'll be what we're starting with. They'll be fixing stuff up, but we need to start with fixing that teleport bug. We will be working on the scream function, but most of the episode is based on fixing that teleport and making it work. To start with, we quick fix the teleport so that we could actually test the rest of the stuff. So it won't change forms mid-charge. Basically, we just put an else statement to say that, don't change forms if we're attacking, essentially. So we started using this ghosting function to test out a new way of changing the enemy's forms. So basically, instead of having a series of statements with all these if statements on them, we changed it so if ghosting is true, then it will be ethereal, the color will change, and the F form will be true. If it's false, then obviously the opposite will happen, and then we can just add that to wherever we need to add that to, rather than having a huge statement to kind of randomly change that. We literally just copied the code in the object form function, but changed it so it's a single if statement, and we don't have to think about any of the other numbers. I don't know if you noticed, but we changed the form a lot in the original code outside of the object form. So we changed it every time we attacked. We changed it in the script for attacking as well as in the object form. So I've changed that so every time we change those, it'll use the ghosting functions, and then it's easy to read. You're not having like 4 lines of code each time while doing that. So now it's, 4 to 1. We've basically saved 12 lines of code. We can see a lot better what's happening, which is kind of the important part about functions, to see what's happening, and it makes it easier to kind of get it around in your head. So onto the scary parts. We need to spawn the enemy on an analyst around the player. So fun new word. Basically, it's a 2D thick circle, I guess you could say. It's like a ring around the player instead of a circle, and it's like in between this and this. So it won't spawn inside the circle, it won't spawn outside the circle, it will spawn inside one circle and outside the other circle. So it needs to be just outside of the range of our player's light, which our player's light is 55. That's our range. I don't actually know what measurement it's in. I would, like, in my head, I'm thinking pixels, right? But that doesn't make sense because the game's too big for it to be 55 pixels. I don't know what code It could be like fake meters kind of thing. I don't know. But our radius is 55, whatever number that actually means. So I'm not a mathematician. I didn't know the code for the analysts. And so I actually like looked up an equation, like a function. If I knew, I don't even know the word for analyst till I looked this all up. So if I'd known that, I probably could have looked up the actual equation and figured it out myself. But instead I looked up how I actually just do the radius thing. Basically that's my Google search. So I did some searching. I found a function created by a guy called Amolk on the Unity forums. So, shout out to them. And the code basically worked exactly how I needed it to work. It returns a vector 2 within the analyst around the player, but we are using a 3D model, obviously. It also receives a minimum radius and maximum radius in like a float situation during the function. The purpose of that is to constantly change the function. So you would be using that if you're needing to change where people spawn at different points. It would actually be really good to reuse this code for other enemies, for randomly spawning things, in like a roguelike type deal. But at the moment, we're just using it for this boss. So we removed the minimum and maximum radiuses because we didn't actually need them. Because we have the numbers, we want the numbers to stay pretty much the same. Yeah, so in the future, if I decide to add kind of things, I could change it to fit the player, but until then, it'll just be that number. So if you're wondering how it works, the original function times the random circle with the origin to get the random direction. Then it picks a number between the minimum radius and maximum radius to get the distance. So if we've got a direction, we've got a distance, we know where it needs to spawn. So it makes a vector 2 by multiplying the direction and distance and then adding that to the original point. So we've got the original point, which is the player, and then we just add the direction and distance to figure out the point in the circle, and it will spawn it in this circle. So all we have to do is make the enemy's x and z equal the points x and y, which we've already done. We just need to change the function so it's the analyst instead of the other code we had previously. Fun fact about C#, when you type void at the start of a function, I didn't realize this, but that void actually means nothing. Obviously void means nothing, but it means that that's what you're returning from the function. So if you're not returning anything, void is fine. So void update, you're never going to return anything. Good. But I needed to return a vector 2. So I changed the word void to vector 2, and then it knows that I'm returning a vector 2 every single time. So that's what you know now, that it isn't with other codes, but for some reason C# does that. So because I have terrible version control, and this is like more of a test than a full game kind of thing, I just commented the old spawn in radius code in case I messed up, but I don't think I did. And we just tested it as it was. And it works pretty well. But we spawn in a really small area around the player because I didn't realize how small the radius was being done originally. So I had to change the distance to 55, that kind of thing. I actually changed it to 30 to 60, so minimum 30, maximum 60, but I'm gonna maybe make it like 50 to 70 in the future. So like there's a chance it spawns inside of your light radius, but it's a very low chance kind of thing. PSA. Before we get any further, object-oriented programming rule number 1 is pretty much never reuse code if you can help it. Use loops for iteration of code. So like if you're adding things constantly, you wouldn't write, x plus 1, x plus 1, x plus 1. You would do a for loop and just keep looping it till it's the right number. And functions are for using functions. So if you need to calculate something, you would have a function and then you would just add a number to the function at random when you need to add the number. So we teleported the player twice in the script at different points, and we will do it again for other attacks. So we needed to go, okay, let's make that a thing. Let's respawn it. So I removed the script and pasted it to a function called reset position. Now, the reason I did the reset position function instead of just using the analyst function is because of the fact that we could reuse the analyst for things that aren't resetting positions. Basically, reset position does the teleporting that we've been seeing earlier, the same code as the teleporting, but we can call it whenever we're in the code just by writing reset position bracket and bracket. So after this, we actually realized that there was an issue. All the moving code made the teleporting break once again. So to fix it, we added a boolean to the fear function that tested if it was already attacking. So basically when we shined a light at it, it turned into a corporeal form. It was being hit twice. So basically we were hitting it. It was turning corporeal, and then we were hitting it while it was corporeal and running at us. And so it was teleporting but it was still attacking, so it chased us. So we had to figure out that it was attacking so it didn't get affected by light. Yeah, so it won't be able to be attacked twice. It'll have like a cooldown before you can attack it again. Because obviously, you know, you can't just keep flashing the light at it because otherwise it would die. I kind of want to give it a small health bar, and I want to give the character a small health bar. So like it would have like, you know, 10 hits and it's dead kind of thing, but you would need to make sure your hits count. So if it just kept hitting it, it would die instantly. Yeah, so we fixed that bug, hopefully for good. If, you know, we'll get there when we get there, I guess. So, fun fact, the reason I started this episode was to work on the scream function, and we're finally here. The enemy's gonna basically yell your ear off, but it will also do damage and knock you back, which is good because it means that you can't flash your light at it, hopefully. It'll push you back to out of distance. It was really embarrassing, and I tweeted about what happened while I was doing the scream function. So I won't show you everything that I did up to the point that we're going to show you on screen, but I tried to figure out for ages how to move a player. I was like, okay, we could use a vector3 dot translate. We could use not translate, vector3 dot move towards. We could use like just kind of teleporting them and making like a knock animation kind of thing. It was really hard. We were trying to access the rigid body, but we couldn't access the rigid body because we don't have a rigid body on our character anymore because there's no physics elements. There's a lot of good physics elements for like pushing something back, like add force, for instance. So it took me a really long time to realize we had moved an object back really fast before in the Goblin code. It's almost the exact same code. So remember how they get hit by light and they run away? Guess what running means in this context? You push the object backwards. There's no animation, so you're just pushing it backwards at the moment. So yeah, with the right animations and a greater amount of speed, it'll look like you're being thrown instead of pushed. I could also maybe have like a, what do you call it, an arc. So you get thrown up a little bit too, because that would help with the throwing back kind of thing. So yeah, to start this script, we started typing in the scream function, and we needed to turn the enemy corporeal with our ghost function for obvious reasons, because it's attacking. We needed to use the form store function, so we didn't make it, or form store variable, so we didn't make it randomly ethereal again, of course. And we made a float called player distance, which was the distance between the enemy and the player. We also had to make a new boolean called s_started. It's called s_started because scream started. I might change the name of it in the future so it's a little bit easy to remember, but that's what it is for now. We also had a variable called start distance, or start dist is what we've written, which is the distance between the player and the enemy at the beginning of the function. So basically, it's the player distance at the very start, and then the player distance will change, but the start distance will not. And that's because we have like a boolean for the s_started, and s_started is like, so it'll add to the thing, and then s_started will equal true, and then it can't add to it anymore. So it'll just go, okay, this is the start. I try to look for different ways to do that, but I thought that was our easiest way at the moment. But yeah, this is really important, the figuring out the start distance, because otherwise you won't figure out how far it's been thrown, and you will just be throwing it back constantly, and we don't want that. We want to be able to move our character. So yeah, basically we have an if statement that checks if the current distance between the player is shorter than the distance plus 40. We might make it plus 55 or plus 60 even later, but plus 40 works for now just to test it, because it means that we can see ourselves being thrown back. So the function to throw the player is the exact same from our episode How to Program Fear, which is actually episode 2. Like we're reusing code from our second episode for the new boss, but we're doing it to the player character instead of the enemy, which is the only reason my head couldn't kind of get around that fact. It was like, hang on, but I'm doing it to my character. What do I do? And I don't know why my brain couldn't handle it, but it couldn't. Yeah, so that's pretty much everything we did that episode. We bug fixed our teleporting system twice. We allowed our enemy to spawn in an annulus and not a radius, which is really important for getting this boss fight to be functional and scary. And our enemy now throws the player when it's attacking. So we haven't completed our scream yet. There's still like a few more mechanics. We need to make it vulnerable to attack for a second or two before it actually attacks. And the scream mechanic does it randomly. we were using it as a alternative to the charge, but the scream mechanic is not going to be a charge attack after I hit it. It's going to be an actual attack that happens at a random point. So we're going to have to add that at some point. Yeah, so keep an eye out for the next video, and we'll hopefully complete the scream mechanic and try and make a more like cohesive boss fight. So I'll actually start like making attacks come at random times, that kind of thing. Yeah, so that's it. Thanks for watching, bunnies. Please leave a comment if you enjoyed a video or needed something explained. Subscribe if you haven't already. Like the video for more content like this. And I will see you in the next one. Bunny out.